All right, well, this is our future structural modeling project discussion. We've been having our challenges with Google Hangouts here this morning, but I think we've effectively been able to get the information recorded and on the web. And we've had a lot of information presented. Actually, I believe creates an excellent context for the discussion of where we're going to go and what we're doing now. So what I have on the screen right now is the read ahead for our monthly structural modeling project meeting, which basically is this Saturday. We are working on diving more specifically into the areas of relational properties, set ordering, those types of things. The material we have here is directly from the Science of Generic Design Appendix 1, where it talks about the information that Kevin did quite an excellent job of presenting in the first history session. And it talks about Peirce, the Russell, Whitehead, Harari, all these people, and essentially their impact and contributions to structural modeling. I think one of the more interesting comments here in this particular part is, and highlighted right here, is what it said is this process was designated interpretive structural modeling, but in retrospect, it might have been better called relationship mapping. And of course, we've come up with the concept of an abstract relation type, which details all the information about each relationship map. So we have a specific logical group. We basically take a natural language relationship. We then detail what the prose, the structured graphics, and the mathematics are to actually represent that specific component. And that's where we are today in our structural modeling project, is we are addressing each one of these types of relationships individually, and then creating a web application that demonstrates it, a simple web application. So that's where we are. We've done the north of relation, which I talked about in our last hangout. And when we have a number of these, right, when we have a number of these specific relationships, then we need to be able to integrate them. And Kevin and I were just chatting about, well, how do you do social networks? How do you dynamically integrate these over, periods of time and space and distance? And the one of the ways to do that is using a concept called a quad or a tapestry. We find that within Warfield's approach, what he called the 4-level inclusion hierarchy for design, and this is what's called a quad. You start with your design options at the base, and then dimensions. These are the design attributes and characteristics that are important. So we have a lot of options. Then we have what are the constraints or our dimensions. Then we create clusters of our candidate designs. And then, of course, out of that, we get our desired system design. So these 4 things are in an inclusion hierarchy, and an inclusion hierarchy is irreflexive, asymmetric, and transitive. So we're starting to use our logical properties now to talk about the structure of each of these systems. So as a quad, this specific inclusion hierarchy has all the options at the bottom. You're going to have more options than, selected components, dimensions, and clusters, as we saw before. And this is a way, just a basic way of organizing the selection of any specific design. But a key aspect now that we're working on and thinking about is, oh, well, you can weave these into tapestries. And these specific tapestries then will go where you have from the options, from many options, and you might pick one option at this level, and at this level would feed into the options at another level. So these are the types of activities that we're going to be working on in the future. And we will be looking at, okay, what's happened here? We now seem to have, all right. Well, we're going to basically appear to have a video and audio problem. I don't know if this is going out. I will stop this specific broadcast and we will continue next Saturday.